So measurement of dielectric loss. So the concept we have to discuss today. So before going to the measurement, first let us discuss some introduction about dielectric loss. Try to concentrate here. Okay. So dielectric loss, an efficient electrical machines. Okay. Okay, this is an efficient electrical material, suppose a varying amount of charge storage with a minimal dissipation of energy in the form of heat. Okay. This heat loss effectively termed as dielectric loss. So this is the definition. So what is by dielectric loss means? This is the definition. Okay. Next, it can be safely parameterized in terms of with the loss angle delta or corresponding loss angle tan delta. It's clear. So it can be parameterized loss angle delta or loss angle tan delta. So like that. It's clear. Then there are essentially two forms of dielectric losses. First one is conduction loss. Second one, dielectric loss. In conduction loss, the flow of charge to the material is dissipated in the form of heat like this. Dielectric loss, dissipation of energy because of charges and is dissipated in the form of like this manner. Dielectric loss is high, means there is a displacement of current is high in a dielectric material. Okay. Then equivalent circuit of a dielectric material. Okay. So let us assume dielectric material. So in between two plates. Okay. So if it is if you are applying the high voltage to this dielectric material, okay, the electric field is established in between these two. Okay. So when you are considering the one lumped element model, just like a capacitor, okay, in series with one resistor. Okay, this is called equivalent series resistance. That is called ESR. The equivalent series resistance represent losses in the capacitor. In good capacitor, equivalent series resistance is very small. In bad capacitor, ESR value is large. Okay. Understanding dissipation factor, it is a measure of loss rate of energy because of oscillations in dielectric due to applied AC voltages. So it can be phasor diagram can be written like this, drawn like this manner. So equivalent series resistance with the equivalent capacitance, and then tan delta is equal to ESR divided by XC. So this is the tan delta. Based on the tan delta loss factor, we have to explain the concept of dielectric material properties. The tan delta testing, try to consider here. The insulation of the cable, so you have to take the insulation of cable is like this. It is used to measure the deterioration of the cable. Okay, it provides an idea of the aging process in the cable and enables us to predict the remaining life of the cable. It's clear. Performing tan delta testing, we have to perform the tan delta testing by applying this high voltage into this cable. Okay, the test voltage is applied to the cable. Based on that, we have to measure the dielectric. Okay, so properties of the dielectric materials. Based on voltage magnitude, we have to say the properties of the cable. Okay, healthy insulation would produce a straight line manner. So by using one of the bridge, by using one bridge that is called shearing bridge. Based on shearing bridge, we have to explain the concept of dielectric material properties. Okay. In cables, so we have to find the dielectric material properties. So one of the scientists, his name is Errol Shearing. So he's explained about how to find the dielectric losses. It has a greatest advantages. Balance equation is independent of frequency. So all of you try to concentrate in the diagram. In this diagram, C1 is called capacitance whose capacitance has to be developed. R1 is called a series resistance representing the loss in the capacitor C1. C2 is called a standard capacitor, and R3 is a non-inductive resistance. C4 a variable capacitor. R4 a variable non-inductive resistance in parallel with a variable capacitor C4. Next, calculation of tan delta. All of you can try to consider here. So this is the sharing bridge. Then sharing bridge is used to measure the capacitance of the capacitor, dissipation factor, and measurement of relative permittivity. By using this, we have to measure these are the different type of concept. First, C1 is called unknown capacitance. R1 is called electrical resistance, and C2 is called standard capacitance. C4 is called variable capacitor. Then R3 is called pure resistor, that is so non-inductive nature, and R4 non-inductive resistor connected in parallel with capacitor C4. Now, the supply is given to the bridge across the A and C. The detector is connected between B and A, you know well. From theory of AC bridges, the at balance condition, based on balance condition, bridge balance condition, here R1 plus 1 by j omega C1 into R4 plus 1 by 1 plus j omega C4. So multiplication of this arm into this arm, okay, is equal to multiplication of this and this. So this is the expressions we are getting like this. So simplifying these equations, so we will get like this. So multiply, so like this inside. So R1 R4 minus j R4 divided by omega C1. So simplifying, so we will get like this. So then equating the real and imaginary parts and separate, we will get R1 is equal to R3 C4 divided by C2. And C1 is equal to the C2 into R4 divided by R3. So based on the phasor diagram, we have to find the tan delta. Okay. So the voltage drops across the resistors, and also we have to find, okay. So they are the different type of voltages, E1, E3, and E2, E4. Based on that, we are draw the phasor diagram of the, okay. From phasor diagram, sharing bridge phasor diagram, calculate the value of tan delta. So dissipation factor, generally is called tan delta, dissipation factor. The tan delta is equal to omega C1 R1. Okay. So last factor, tan delta is equal to omega C1 R1. That is equal to omega into C2 R4 divided by R3 into R3 C4 by C2. So by substituting these values, so we will get tan delta is equal to omega C4 R4. Okay. So this is about some simple and all of you write here. So first, what is meant by dielectric loss? Okay. Dielectric loss measure the quantity of dielectric materials inherent dissipation of electromagnetic energy converted into heat. All of you write this. Okay. Dielectric loss measure the quantity of dielectric materials inherent dissipation of electromagnetic energy converted into heat. Any losses into converted into heat. No? Okay. Then maybe dielectric loss or conduction loss or dielectric loss. Any type of losses, first it will be displayed into heat. Okay, there is the definition. And then the dielectric loss can be expressed in terms of loss angle tan delta. Based on loss angle tan delta, we have to express the dielectric material properties. If the tan delta is lesser, we can say that this is the good type of dielectric material. If the tan delta is high, that means dielectric losses are more. Okay, by using sharing bridge, we have to measure the tan delta. Okay, that is one of the experiment to measure the dielectric losses. Okay, an efficient dielectric material supports a varying charge with the nominal dissipation of energy in the form of heat. Okay, this is the simple concept about dielectric material. It's completed. dielectric loss angle. All of you write this is dielectric loss angle. Tan delta is called a loss angle or dissipation factor, testing or loss tangent. Can call as tan delta is called as loss angle or dissipation factor, testing or loss tangent. Okay, these are the different names of the loss factor that is called tan delta. Then helps to determine the quantity of dielectrics. It is used to measure the quantity of the dielectric material based on tan delta. Okay, it has to determine the quantity of dielectrics. It's clear. And then the cable and its insulation is compared to a parallel plate capacitor. So cable is just like a capacitor. No? Cables are just like a capacitor. So by comparing the parallel plate capacitor, by taking the parallel plate capacitor, we have to find the relation between a loss factor. So how the loss factor is depends on. Okay. So the parallel plate capacitor, just like cable, is a resistance, a very high insulation resistance, and parallel with one capacitor. We have to indicate a circuit like this manner. Okay. And by using phasor diagram, so we have to find the loss factor that is called tan delta, that is called equivalent series resistance IR divided by IC. Okay. Based on resistance of the cable, equivalent series resistance, and also current flow into the resistive element, insulation resistance, and current flow into the capacitor. That is called current flowing to the capacitor is nothing but displacement current, and current flow into the dielectric material is called displacement current. I mean, current. If the current flowing through the insulating material is high, that losses will be high. Okay, so that means the displacement current then between two plates of dielectric material is less. Okay, if displacement current will be high, then when dielectric material breakdown takes place, it will be acting as a conduction current. Okay, finally it will be acting as conduction. Perfect cable insulation. So delta is equal to 0. The last factor delta is equal to 0. There is an angle between these two. A resultant of this IR and IC and IC between these two. The delta is very, very less. Okay. Delta is equal to 0 for perfect cable insulation. Okay. Tan delta helps to find out the life expectancy of dielectric material. Okay. So based on tan delta, we have to find out the life expectancy of dielectric material. Based on this factor, we have to tell the dielectric material life of the dielectric materials. 6 months or 1 year, or based on that, or 10 years. Based on this factor, we have to find out the life expectancy of dielectric material. Okay, I'm already explained in an animation video, so yeah, I think you know well. Okay, this by based on loss angle tan delta, we have to express. So there are the two different type of insulation losses. Okay, all of you draw this diagram. So this is about measurement of dielectric loss by using sharing bridge. Okay, you will study in measurement subject clearly each and every concept. You can easily understand by this concept is also there in measurement subject. Okay, you can easily understand if you are following that measurement class. Okay, so I will provide this lecture in YouTube, so you can go through the YouTube channel and you can easily understand. It's clear. So this is about today's lecture. So measurement of dielectric loss, measurement of dielectric constant and loss factor. Okay. This is enough today. So remaining concept we have to concentrating on remaining. So for mid exam up to electrostatic voltmeter, I will give up to electrostatic voltmeter. Okay, for third unit. You know well, from first unit 2 questions and the second unit 2 questions, third unit 1 question. It's clear.